Hi everyone. Today I'm gonna record a video about the differences between a smooth surface and roughened surface. Now we will put to these two different pictures as smooth surface and roughened surface, and we will count their number of cells, and we will evaluate their differences. Firstly, actually, before starting, I did required process, but I will explain how to do it firstly, and after that I will explain the differences. Firstly, we are opening a file from the ImageJ, and our final, as we know, roughened surface. We will start with roughened surface. Now we have a picture like that, but it has some problems. Firstly, we will solve these problems. Firstly, we will adjust the image to the type 8, 8-bit, because the program is working for in that standard. After that, we are adjusting threshold. We can choose different colors to detect the cells, and this is the a measurement, a scale that remove the, like, you see these faded particles. And when we apply, for example, we can look from here. You can see when we go towards the 255, it's getting it's removing the all red particles. We don't want it. We want the full cell attachment, but we don't want it also because it's impossible to detect the number of cells in that position. So we are choosing 98, or let's say 87, 90 processes, because this is better. We are seeing the number of cells, we are seeing the cells, and we can separate them. We are setting a threshold from the 85 scale, and we now set our threshold. Now we are coming to the analyze part. Process part, binary. We will we will set the convert to mask. What does it mean, convert to mask? Convert to mask is taking like a screenshot. Think about it. Take a screenshot of the red parts and deleting the let's say white and dark background from the memory of the computer. Let's say we are saying convert to mask. Now there is two different colors to initiate cells. We can see everything better, let's say. So again, process, we are saying that binary, and that time we are saying that fill holes. We cannot see nothing maybe, but there are differences. What does it doing? For example, there is a hole between these white places. It's filling these holes with white color again. Why it's doing that? We don't want to create a complication, let's say. After that process, again, binary and watersheet. What the watersheet is doing, for example, we did it in here. Let me see, we did it in here. What's the watersheet is doing? Watersheet is separating the cells by putting a line, a dark line, and this dark line provides a separation of the let's say cells. After analyze particles, we have the let's say we have the initial numbers, and these numbers are the proper, let's say, measurements, and we will show the outlines, and we will check the number of we say that display the results, and after that we okay. Sorry. Yes, you can see that we have the let's say cells. These are the cells. Cells are signed with black lines. You can see that these are number of cells. You can see that he took the cells and he removed the other parts, and the red, you see that these red dots are the our cells. But yes, these are our results. We have 451, let's say, cells, and their areas in terms of nanometer is given, and we can see, we can calculate number of cells in that method. After that, we save it, desktop, save. Yes, and we close it. Now we will do the same process for the roughness surface. We click, sorry, yes. Now we will look at the another. Now we will look on smooth surface. We opened the smooth surface and we will do our processes in smooth surface. Now we will look at image, type, 8-bit, process, image, adjust, threshold. Now we have the same scale. I think this initial scale is good because there is no so much detail, let's say. Set 80 is better. Let's say this time white and black and white. Set, this is better. After that, we are closing it. Process, same processes we are doing. Convert to mask, process, binary, fill the holes, but this time there is no so much holes. Binary, water sheet. You see, we applied water sheet. Process, analyze particles. Same results, okay, and we have now. And you can see that again we have cells, but the number of cells this time is 179. We can see that roughness surface have more cells attachment compared to smooth surface. We can explain this situation like that. I want to show also, I don't have, I think, results. First results, but I cannot see the second results. Results, another results. Now let's say we solve the differences. Why we have such a differences? We analyzed that in our lesson. In our lesson, as I remember, once upon a time, we had two different spacemen in one of articles, and these two spacemens was from one of them smooth surface and one of them, let's say, roughness surface, and we were looking for their cell attachments in terms of osteoblast cell. What osteoblast cells? Osteoblast cells is a cell that turn tissue to the bones. We can say bone cells, and these cells are attached to the generally implants from the body, and this is important in terms of osteoblast cells. So we can see that easily as roughness surfaces are more successful to keep osteoblast cells in terms of keeping and providing spreading of osteoblast cells. And we saw that in ImageJ program also by showing roughness surface have more cell attachment compared to smooth surface. That's all for me. Thank you.